Welcome to everybody. Probability and stochastic processes. In this lecture, we will see conditional probability, disjoint events, total probability, and Bayes theorem. I am Dr. V. Ayambillai, Professor EC GRIT, Hyderabad, 90. First, let's see conditional probability. Conditional probability is about the probability of happening of an event on condition that another event has occurred. What happens is that a new sample space is defined by condition imposing event, and we determine the chance of an event which is a subset of the condition imposing event. The conditional probability of the imposed event will be more when it gets associated with a condition imposing event. Let's see an example. Suppose that in a certain city 23% of the days are raining. Thus, if you pick a random day, the probability that it rains that day is 23%. That is, P of R is equal to 0.23, where R is the event that it rains on the randomly chosen day. Now, suppose that I pick a random day, but I also tell you that it is cloudy on the chosen day. Now that you have this extra piece of information, how do you update the chance that it rains on that day? In other words, what is the probability that it rains given that it is cloudy? If C is the event that it is cloudy, then we write this as P of R by C, the conditional probability of R given that C has occurred. It is reasonable to assume that in this example, P of R by C should be larger than the original P of R. Let's see another example. This time we'll see a quantitative example. I roll a fair die. Let A be the event that the outcome is an odd number, that is, A is equal to 1, 3, 5. Also, let B be the event that the outcome is less than or equal to 3, that is, B is equal to 1, 2, 3. What is the probability of A? What is the probability of A given B? That is P of A by B. The P of A is equal to number of possible outcomes for event divided by number of possible outcomes in rolling a die. Please note that this is based on equal likelihood. So P of A is equal to 3 divided by 6, which is equal to 1 by 2. A formula for probability of A given B, P of A by B. Let's call condition imposed event as A and condition imposing event as B. The conditional probability of A given B can be written as P of A by B is equal to number of possible outcomes of event A coming within the total outcomes of event B divided by total number of outcomes of event B, that is equal to number of A intersection B divided by number of B which can be written as number of A intersection B divided by number of S divided by number of B divided by number of S, which is equal to P of A intersection B divided by P of B. So we have got a formula for P of A by B. Please carry out this exercise and submit this to my table. I roll a fair die twice and obtain two numbers. X1 is equal to result of the first roll and X2 is equal to result of the second roll. Given that I know X1 plus X2 is equal to 7, what is the probability that X1 is equal to 4 or X2 is equal to 4? Please verify your answer to be 1 by 3. Now let's see disjoint events. Events which have nothing in common among each other and in which only one can happen at a time among them in an experiment are called as disjoint events. These events are also called as mutually exclusive events. In an experiment of coin tossing, events of happening of head and happening of tail are called mutually exclusive. Next, let us see the concept of total probability. Let's explain this with an example. I have 3 bags. All the 3 bags have some red balls and some blue balls. I want to find the probability of selecting a red ball. We can split into different events. Event of selecting bags and event of selecting a ball of some color. We can say that events of selecting bag 1, bag 2 and bag 3 are B1, B2 and B3. Selecting a red ball has link with the selection of bag 1, bag 2 and bag 3. We will name selection of bags as B1, B2 and B3. We will name selection of a red ball as event A. We can draw the following picture. See in the picture, B1, B2 and B3 do not have anything common, and A is embracing all the 3. The part of A that corresponds to B1, we will call it as A1. Part of A that corresponds to B2, we will call it as A2. The part of A that corresponds to B3, we will call it as A3. We can generalize now. Let B1, B2 and B3 be mutually exclusive. Let B1, B2, B3 and so on be mutually exclusive events. Let B1, B2, B3 and so on be mutually exclusive events, and let capital A be an event embracing one or more than one of the events. We can write that S is equal to union of Bi, where I is index. A can be written as A is equal to A intersection capital S. That is equal to A intersection union of Bi. which is equal to union of A intersection BI. Now note that the sets A intersection BI are disjoint, since the BI's are disjoint. Now we can write that P of A is equal to P of union of A intersection BI is equal to summation of P of A intersection BI with I index is equal to summation of P of A by BI into P of BI with I as index. Let's see an example. Now let's apply quantitatively to the this concept to the above set bag example. I have 3 bags. Each contain 100 marbles. Bag 1 has 75 red and 25 blue marbles. Bag 2 has 60 red and 40 blue marbles. Bag 3 has 45 red and 55 blue marbles. I choose one of the bags at random and then pick a marble from the chosen bag, also at random. What is the probability that the chosen marble is red? Let R be the event that the chosen marble is red. Let BI be the event that I choose bag I. We already know that P of R by B1 is equal to 0.75, P of R by B2 is equal to 0.6, P of R by B3 is equal to 0.45. We choose our partitions as B1, B2 and B3. Note that this is a valid partition because firstly the BIs are disjoint, only one of them can happen, and secondly because their union is the entire sample space. As one of the bags will be chosen for sure, that is P of B1 union B2 union B3 is equal to 1. Now using the law of total probability, we can write P of R is equal to P of R by B1 into P of B1 plus P of R by B2 into P of B2 plus P of R by B3 into P of B3 is equal to 0.6. This is an exercise for you, an exercise involving communication systems. An elementary binary communication system consists of a transmitter that sends one of the possible symbols, a 1 or a 0, over a channel to a receiver. The channel occasionally causes errors to occur so that a 1 shows up at the receiver as 0 and vice versa. Find the total probability of receiving a 1 and the total probability of receiving 0. In this problem, take transmission of 1 and 0, take as B1 and B2 events. Take reception of events 1 and 0 as A1 and A2. Now probability of A1 and probability of A2 both will come under the concept of total probability. Given, let P of B1 be 0.6 and P of B2 be 0.4. Let P of A1 by B1 be equal to 0.9 and P of A2 by B1 be equal to 0.1. P of A1 by B2 is equal to 0.1 and P of A2 by B2 is equal to 0.9. Please verify the answer. P of A1 is equal to 0.58 and P of A2 is equal to 0.42. In case of doubt, you may please consult people's book. Next, Bayes theorem. This we will cover in the next session.